This variation that I'm doing, first of all, called linearly vary, is a way of being able to adjust the width and or slope of a section on your design. And really, the best approach to show you this is actually to use the slope adjustment on that tool. And what we're going to do is sort of super elevate this corner. So we're going to go from -3%, transition to a +3%, then back down to -3% again. So we've got this one-way crossfall going around this corner. Linearly vary is really perfect for that kind of thing. If you're going to be looking to make significant horizontal adjustments with your code, I would suggest that you start looking at the match to alignment variation, which is what we'll be covering not long after this one. So I've got model viewer fired up. Todd, can you see my screen?
Sorry, I'm muted. Yes, I can.
Furiously unmuting. Okay, so I'm just firing this up so we can see what's going on. And I'm really going to be applying mostly all my variations straight from the section data form and cross-section window. So I'm just going to left click on an element or a bit of line work, hover over one of these codes and view cross-section. And what we're going to do is be pushing this slope here from around chainage 150, I expect, and I'm just going to scroll. So if you scroll on this area of your cross-section window, you can actually scroll through your cross-sections nice and quickly. So from 150 to 170, I want to be transitioning from -3 to +3 on that left side. So to do this, with the right click, have a look at the code that's down the bottom of the cross-section window, because that is your guide. That is going to apply a code to the variation for you, which we can change. So I'm going to hover over LEB, right click, then hover over add variation. And this really goes back to what we were saying at the start, inserting, deleting, and modifying. Todd's actually done these. I'm going to be going modify, and we're going to be going vary section slope and width. Because I've used this form, a load of this is auto-populated. So in respect of the chainages, actually these do need a tweak. So I'm going to be punching in 150 to 170. This is the transition. The code's already populated. The way in which this this next part works is that you can then choose to change the width and or the slope. And this is the bit which catches people out, I would say, where people go, well, I want to set the width and I'm going to say 0 because I don't want to do anything with it. What you're actually doing here is you're setting the width of the LEB code from the center line to be a value of nothing, which obviously we don't want to do. So this is where you can use increment value. So increment says, I want to add nothing to the existing width or subtract nothing from the existing width at chainage 150 and 170. The same goes with the slope. Now, I'm going to be using set value, but I could add a value to the existing slope if I wanted to. The only bit is this, you'll see that it says slope or vertical. Now, on a variation that Todd did, you actually had the option of picking a slope or vertical and then defining what that was in here. We don't have that option. So the question is, well, how do I know that I'm putting in a slope in here or a vertical distance, say 0.1, 100 mil? It really comes down to your section that you have created in your template. So I'm just going to move this off to one side. For every section that uses a slope, which this one does, LEB, when I punch in a value in here, the software will expect that number to be a slope value. If I adjust any of these codes, invert, top of curve, back of curve, they were created using the vertical distance, which means that if I punch in use or edit, sorry, any one of those codes in here, it will expect that the number I put in here is a vertical distance, such as -40 mil or plus 125 mil. So I know that the LEB has been created with a section that uses a slope. So in here, I'm going to punch in 150. I want the slope to be, as we've seen here, -3%. By the time it gets to chainage 170, I want the slope to be a +3%. So I'm going to put a +3 in here and click apply. Now, as soon as we do that, a lot will happen. Not only will it close the form down, but it'll also go ahead and make those adjustments for me through the model here. As you can see, everything happens. So if I now scroll through my cross sections, 150, 152, you can see at 160, at the midpoint of the transition here, 170, I'm at that transition point. Now, 178, you can see I'm now back down at -3%. So I actually want to maintain this transition. So rather than maybe going through add variation and it going through that same process again, I'm just going to open up the section design data form, which really gives me a summary of what's going on at chainage 178. And you can see there's no variation. Okay, that's because there is no variation being applied at 178. If I scroll, just using my mouse here, just scroll back, 170, there is a variation being applied. So this might catch you out initially, It's a really great tool because it shows you a snapshot of the cross section, but obviously doesn't allow me to see what's happening at maybe a cross section when there is no variation. All right, so which is what's happening here. So to make life easy, I'm going to stick with 170 in this form, and I'm going to just copy the variation. I'm going to copy it. Let's give it a couple of seconds just to get its act together here. It's now copying, and effectively what we now need to say is that, look, we're going to use that same variation, but I want to do from 170, and I'm going to go around to about 210 here, around to 210. Leave the LEB as it is, don't change the width, but actually what I want to happen is for the value or the slope currently at 170 to be maintained, so that's 3, and all the way around to 210 also be maintained as 3. So we're sort of creating some sort of super elevation as we're going around the corner here. I'm going to click apply, and not much is going to happen here because apart from model viewer editing and the contours in the background, we can't really see what's going on. So I'm just going to scroll through my cross sections here. 170, 178, and you can see +3 is being maintained all the way around as far as 210, then it drops back again. So how can we get that last leg in? So this is a great tool that we can use. So I'm going to flick back into here, flick back to the cross section where these variations all exist, copy the entry. The reason why it's taking a bit of time is it's because it's when it's copying this entry, it's actually applying it. So it's copying it and applying what I've put in. So we're going to pop into here and say, look, from 210 to 230, this is the transition back down again. I'm going to be working with the LEB. I'm not going to change the width, but when it's at 210, I want it to be at +3%. But when it gets to 230, I want it to drop back down to -3. Click apply. And what we'll now see in the background is a number of different things happening. Model viewer is updating because it's open. This is rebuilding the models as we go through. And obviously because we're at 170 here, it's not showing what's going on, but that's fine. And we can flick through, and what we might do is just show you what's happening in the design data form as well, just to give you a heads up. Here are those variations. Now, obviously, as we said at the start, there are no comments. You can't add comments into this. So just be aware that you could probably now go in, as Todd showed you earlier, and add a comment to explain what is happening with this particular variation. You can see as I scroll through here, I'm now going from 180, 190, 200, 210, and back down to 3, and I'm not sure I got that variation quite right, so apologies, bear with me. 210 to 230, +3.
You did do it right. You just did it over 20 meters. So when
I did it over a very short distance. There you go. So it just shows you how that can be managed. Now you could do that with any code, guys. If you need to move the footpath out linearly, as I said, with no real curvature going on, you can use that to adjust the footpath in the same manner. It's a way of transitioning. There could be a case for saying, well, you could just do that with a template. But it really is up to you. I would suggest that really for changing the elevation data on a section, that particular variation is a good one. So I'm going to close the section data form. So that's linearly vary. The other one I'm going to show you is I'm going to close down the Q&A because that's in my way now, is the match to surface. Now, match to surface is one of those ones which I've seen used in a strange way. I've actually seen it used with match to surface and match to alignment at the same time. Whereas they're actually included in the same variation. So what we're going to do is move Eyelet Street over here. Now I've got some similar type of geometry to what Todd has got, not quite the same. I'm going to match this REB code. I'm going to open up a cross section, match this REB code onto the natural surface at that particular spot here. All right. So to do this, we can right click over REB, add variation, modify section, match code to surface. Because again, it uses the alignment. Wherever the alignment exists, it will use it. If it doesn't exist, it won't. I want to match onto the natural surface, and I have an alignment which is called Eyelet Street REOB. Now I'm going to add a 30 mil adjustment. But you've got the optional alignment, guys. I have seen people use match to alignment and then match to surface without realizing that match to surface actually has this option in here. So you can just use the one to kill two birds with one stone. I'm going to apply that. As you can see, that's moved over. So I'm now 30 mil above on the right bitumen. This is one of the most common variations that I see people using, particularly when you're doing rehab and reconstruction. Another example of this is maybe, and this just shows you how you can use what's known as the optional inside code on that same variation. So I'm going to open up a cross section of road 1 here. And the argument is that we need to have the left boundary code matching onto the existing surface. But I need to maintain the slope of 5% and maintain my footpath slope, and then I'll have a varying slope between my left footpath and my left back of curb. Well, to do this, we can right-click over left boundary, add variation, modify section, match code to surface. Now, it's slightly different. I'm not going to be working all around. I'm actually going to be working from chainage, let's say 40 to chainage 150. I'm going to be changing the left boundary code, matching it to the NS, which is what we're doing now. I don't have an alignment. That's fine. I want it to maintain its current horizontal position. The height adjustment I'm not interested in either, but what I am interested in is the optional inside code. So what this says, and it's better if I just show you in action. So what happened there was when I clicked apply, it moved the left boundary code straight onto the natural surface. But because there's a batter there as well, the two codes are more or less conflicting with each other, but they are there. Let's right click, open section design data. I'm going to left click on my entry that I made here. Now I can now go and edit. Now this form will stay up, so I can decide, well, look, what I want to happen is for the left footpath outer code and the inner code to be maintained, for their section to be maintained. So we go and pick the furthest most inside code that we want to keep. So left footpath inner, click apply. So that maintains, going back into the your template, those section slopes, as you can see there. So if we wanted to, we could put LEB, click apply. You can see it's maintaining the template slopes all the way back to LEB, which is obviously
Remind me never to drive on your roads, Jonathan.
Yeah, please don't. Yeah, or walk on any one of my footpaths because
without a fence.
Without a fence, or just at least some kind of barrier. But look, this could be a retaining structure or something going on in here. But it's a neat way of being able to maintain or connect the cross section together and have that matched up to the surface. So that's matched to surface. I'm now going to just run through match to alignment. I'm going through these fairly quickly, but these are, I've, to be fair, got some of the most simple design variations to have to show you. So it's not too bad. In fact, for the match to alignment, I'm not going to necessarily try this one down here. I'm actually going to just pop down and use this down here to show you how variations can be worked in combination with each other. So remember, folks, I've got the linearly vary, which is adjusting the elevations or slopes on this particular road. What I want to also happen is for the left edge of bitumen to maintain that slope, but to be horizontally positioned on this civil 3D alignment, which I've got in the background. Todd's already done this, but I've actually gone on and turned, and this is just something you should get into the habit of doing, guys. Show your alignments. When you're matching to alignments, really recommend that you go in and turn the alignment on so you can really get validation that what you're doing has worked. So I'm going to right click over LEB, add variation, modify section, match code to alignment. A warning, okay. If I tell the LEB code, which I'm going to in a minute, to match onto this alignment, that LEB code, and this alignment is going around this corner of this road here, just around here. That LEB code actually occurs all the way around here as well. And in some cases, what will happen is the LEB, if you put in this big chainage range, will go, oh, you've told me to match the LEB wherever I see that alignment. I can see that alignment down there, and it will force the LEB, or any code for that matter, across all the way across your design and try and match on. So when you're matching to an alignment, if you have got roads that are certainly they've got geometry that kind of backs onto itself like this, put in a chainage range, which is really the range where you're working. Now I'm going to show you the little picker tool here. So I'm going to click on the little picker tool. When you do that, you'll be prompted down the bottom to left click a start chainage. So I'm going to left click near 160. Then it says, once you've left clicked, select end chainage. And I'm going to go around here to around, I'm way past the alignment, just over here, left click. So that allows you to pick a region. I can refine those numbers. The key thing with the section data form is that when you punch in numbers into this form, you get the sections created. So even if there was no section at these spots, it will create them for you like you're doing in add extra sections or add extra sampled sections. You've also got a couple of other options here, which are the alignment. This is the alignment of road 1. This is not the alignment I'm picking. Current chainage to alignment end and current chainage only. So there's a few different ways in which you can manage that, but you don't get the select region until you run the picker. So I'm going to leave this as it is. I'm going to leave change offset and level. That basically says maintain 3% or maintain my section slope. There is another option in here, which is change offset and keep level. What that one will do is maintain the elevation or level that I have on my road here and simply push it across. I don't want that. I want to maintain my slope, and I want to use the alignment called road 1 left edge of, or road 1 EB widen. Going to click apply. So those two variations have worked in combination. As we just wait for this now, it's doing a few different model updates, and we'll leave Islet Street just for a second, and we can come and have a look down here. And look at the drawing, we can see that that alignment variation has done its job, which is basically to match on but maintain the slope. So just very quickly, if we go back and edit that variation and chose keep level and click apply, you can see it's actually maintained the elevation that was there originally and pushed it across. Now we've got this varying slope, which is maybe what we don't want. Now I'm not going to do anything more to road one, so I'm happy to leave it here. I'm going to flag something, and I did this in the last webinar a few weeks back. These buttons will open up playlists on our YouTube channel and unpack selection of different variations, or how to actually manage changing templates and batters and bits and pieces. These buttons appear all over the place, including the cross-section window. Okay, have a look at them. This webinar will actually be part of the playlist, which is shown when this button is clicked on. So just bear that in mind. Now, the last one that I'm going to run through, I was going to do match to alignment. In fact, I will just very quickly just show you match to alignment on here, because there's an issue with how this happens. I'm going to take the saw cut and match it onto this alignment. By and large, that's not really too dissimilar to what we've done already and what Todd's done. Okay, but there is just one little thing here that you need to be aware of. I'm going to take the saw cut code, right click, add variation, modify, match to alignment. Yep, whole way through, maintain the slope and match it to left saw cut. Not going to bother with the LEB. Todd's already kind of shown you how that process works. It's the same thing. The thing you need to be aware of is that the samples of my road are every 10 meters. So at the moment, if I left click on that line work, you can see that these are the points where it's matched onto the alignment. So if you do find that you're not getting that nice clean geometry from your road matching to the alignment, you can see the difference between the two of them there. It's down to the sampling of your main road. So we can go into add extra sections, click on our road, click OK, and we're just going to use pick, start, and extents. We just want to kind of add by left clicking here, a range of extra sections in a meter spacing to give us that nice smooth geometry as we're matching onto the alignment. So it's an important addition you need to remember. Okay, I'm going to flag this. So this is about matching to an alignment. I see this quite a lot, and people that are designing intersections, just simply using civil site design, they want to put curb returns in here. If you are doing any kind of build out where you're narrowing your road through an intersection, and maybe later on you're going to be creating the curb returns with the curb return tool, it is important that you use an alignment to adjust your edge of bitumen. I don't suggest you use linearly vary. I have seen linearly vary used to manage the edge of bitumen going through. Just use an alignment, far quicker. But you need to do that to enable the curb returns to form properly with civil site design. Okay, so if you have to do narrowing, forcing curb returns into your intersection, just make sure that you have an alignment there to adjust your edge of bitumen all the way through, and then start forming your intersection. So just a quick additional piece of information about how alignments matching to them is very important, and that's a good example. The last one I'm going to show you before we jump into the sort of three miscellaneous is matched string. And if you're not too sure about using profile strings, the webinar that I mentioned at the start of this particular session called Independent String Design is really your kind of guide to how you can create strings independently and have them reference each other in elevation. This example is fairly basic, far more basic than what Todd did. So much so, I think I'm going to try and move along a little bit here. There we go. So the intention is this: we have a very basic V drain, nothing quite as complex as Todd's, but I need that V drain elevation to match onto an elevation of a string. Now that string, profile string, which I've created, is just sitting to the left. I'm just going to just fire it up very quickly to show you what it's doing. So this is a profile string, and all I've done is I've used an auto profile entry, not going into this in any depth at all. Video button if you want to learn how to use reference point. I've told this elevation of this string to be 400 mil below the left edge of bitumen. And what I want to happen is I want the end of this code here, or the V of the code. Keep wanting to say Kogo point. It's not a Kogo point. It's a code. I want the end of this code to match the elevation of this particular profile, which has been generated, but maintain its 4% slope. Now, profile string and match code to string is the way to do it. So let me show you how this is done. So I'm going to right click over left table drain, add variation, modify section, match code to string. I want this to happen all the way through. The code's already picked, and I actually have a load of options. Now I'm going to show you change, offset, and level because that's probably one of the most common. And I'm going to pick my string, which is called Princess Highway left 6 meters. Okay, and apply. So if I went ahead and opened up the vertical design of that profile string a second ago and adjusted its elevations, this would be controlling, the elevation of my left table drain code. So any changes I make in here, I'm going to go open section data so I can show you the other options. Any changes I make to that profile string will adjust the elevations of that left table drain, which can be useful across the board, adjusting footpaths, boundaries, edge of bitumen, you name it. Having a profile string there to adjust the elevation of the code can be very helpful. The other options in here are, well, the first one is what Todd mentioned earlier about disabling this variation. You can technically disable this variation by using hold, offset, and level and click apply. And what that'll do is ignore using the offset and level of your profile string. And I think the only way that we could see that you would ever want to use that is when your variations are being stacked on top of each other. If you had a section where you say, hey, do not use this string, you could say, look, between chainage, I don't know, 30 and 40, do not use this string, but do for the rest. You can add this design variation in and it'll effectively override by saying ignore. This is an ignore one. So if you use change, offset, and level, I'm going to show you the other two on here, which are, again, maybe less useful. First one is change offset, but hold level. So maintain the elevation of my section, which was here, and push it across. Not too dissimilar to keep level with match to alignment. And I'm going to skip the fourth one and show you that in a second. Hold offset and change level. And this is actually using the elevation of a string and using its elevation, but maintaining its current position, its offset. Okay, I don't know why I'm showing you that up there. It would be probably more useful if I'd shown you this up here. So the one that I want to show you, which is probably for me worth a lot more, is hold slope and change offset. And I know many people have used this. This is actually to maintain a slope, which I said at the start, maintain the 4% slope, but match to the elevation of a string. Now, I've actually put this string and this alignment actually in a random position. I haven't actually put it anywhere specifically. It's simply there to control the elevation of the left table drain. So it could be right there. The problem is I don't know where this offset is. It's saying change offset. I never know where that 4% is going to be. It's less likely that would happen on this template because I'm constantly at 3%. So it'll always be in the same spot. But if you were varying your left edge of bitumen, maybe as Todd was doing, matching it to a surface, your slope would change and vary, which means that that spot there would obviously vary as well. It'd be in a slightly different position. So hold slope and change offset is excellent. And this is really the best example I could show you of how to implement this particular design variation. Don't know why I've closed model viewer, but I guess really that leaves us with, for those of you that are desperately clinging on now for the last leg, thank you for holding on. Todd and I are going to kind of go through the last three, and these last three are, and we're going to just present them on the right edge of bitumen of Eyelet Street. These are very bespoke and very specific or niche design variations.
They were written for a very, very specific function in the software quite a long time ago.
Yes.
So if you're not doing this specific thing, they're not going to be exceptionally useful.
No. Now, what I'm going to do, guys, is to show you how you could create different options. I've got an option which shows how these particular variations work. So I'm actually going to import, and I've got one in here called warp and section slope to surface. The amount of people that go, so what does warp do to me? And I'm like, well, okay, let me explain. We've actually got the three variations all plumb one on top of each other. So the one at the bottom is currently overriding these. So I'll delete them as we go through. So I've actually got them pre-created to show you what's going on. All right. Now, Todd, are you happy for me to whittle through these? And do you want to jump in or?
Yep, go for it.
Okay. Okay. So first of all, match sections. You notice it says set code to alignment up here. It's I don't think that's quite right. But the first one I'm running is match section slope to surface. All that does, and I think there's possibly been some miseducation in the past, people thinking that it's using, I think particularly warp, using the points, matching a point onto a surface. What this is doing is taking the section slope between the center line and the code I pick, which is REB, picking up the slope between that point there on the natural to that point there on the natural, because I've told it to use the natural. And then it will maintain, for every cross section between 20 and 60, maintain the slope that is currently calculated between the center line and the REB on the natural surface. So if I flick forward here, 27, that 2.69 is the slope from that point there to that point there.
So it's setting the grade, but the level comes from the center line itself.
It does. So the center line elevation is being set by the vertical design. The REB is being positioned based on the slope from the natural to there. So if my center line was actually plumb on the natural here, it would actually probably be more useful. But the problem is you guys can't see it very well when I've got all these things overlapping. So I flick forward, it's still maintaining it. And as soon as we get to 60, because my center line is actually bang on the existing surface. So this is, I was thinking about why you might want to use this, but the best example I can think is, look, you want your design of your REB or your section slope to match the slope of the existing road. But there's also a case for saying, well, why don't I just match the REB onto the existing surface using match the surface? So this is a very specific, but through every cross section between chainage 20 to 60, it is matching the section start end.
Can I clarify
Please.
Clarify a little bit further on that?
Yeah.
If you just use the match to surface, so you drape the center line on the natural and you drape the REB on the natural, then the software just does a straight regression between the two. So it's a straight line. But if you do the section slope calculated between the two and there's undulations in it, or you've even got another code between them, that's when you're setting the slope, and then yeah, it just gives you more refinement on it, but it's very much a reconstruction tool. So it's yeah, it can be achieved multiple ways. It's not something that I probably would imagine many people, unless they're doing a reconstruction of a road where they're extending the pavement and using this to calculate the slope, but there's other ways to do it anyway. So
yeah,
the nicest part about it is what you're about to show now, I think, which is drop that list down where you had section slope from surface, is you actually can choose different ways for it to be calculated.
Yeah. So end of section, it will actually pick up the slope at the end of my section, being the REB.
Slope.
Instantaneous slope at that point. Start of section would be the center line. The center line to section end would be the center line to wherever my section was. Maybe I had another code going on over here, like Tom was saying, and midway. So yeah, it is a very specific tool, and it can only really be used in a specific circumstance, whereas the other design variation can actually be used in all sorts of different ways, whereas this is kind of, these last three are very, very specific in the way that they are being used. So that is match section slope to surface. If I delete it, see, this is the thing, right? You don't even really see much difference. Warp to crossfall does something very, very similar. It says chainage at surface. So I'm actually going to flick to chainage 20 here.
Just, can I jump in, Jonathan?
Please, yeah, go for it.
So the one that Jonathan just removed is a section by section analysis. So it'll build at each section that you define in the range, whereas warp and warp to crossfall are nothing to do with space, are all about transition ranges. So what Jonathan's about to show you now is more about a transition as opposed to a section by section analysis.
Correct, yeah. So actually what we've got at the very start here, when we say REB, natural surface, is identical to what we just had with match section slope to surface. It's doing the same thing, okay? It is, unfortunately, you don't get the option to pick, but it is just going straight from this section start to section end, looking at the slope, and then you're telling it with warp to crossfall, by the time it gets to 60, what it should transition, what slope it should transition to from chainage 20. So this is the only point where it reads the surface. The rest of this, if I flick through 27, these are all transitioning.
It's just a linear regression.
Linear regression. There we go. 50, 51, 60, we're at 3%. Okay,
and a clarification, it only works at the start of your strings.
Yes.
You cannot do it at the end of a string.
No. So we absolutely know why there would be benefit in doing this at the end of a road, not just the start. But unfortunately, again, it's a very specific and niche tool that works in a particular scenario. But hopefully this explains that. Now, warp to crossfall and warp are very similar. Warp to crossfall says, hey, transition from a section slope on the natural or a surface to a crossfall. Whereas warp does basically the section slope at the start, but it uses a section slope at the end. So at the start, if I go back to chainage 60 here,
I guess the
scroll
idea
back.
here is you could potentially target a second surface that maybe
You
you're
could.
matching from one. I mean, look, they were both originally written for an element that we used to have called the off ramp, and it was all about merging from a main road to a side road or to
Yep.
an off ramp road. And the idea would be that you'd have models of the surfaces that you're trying to transition from and to, which
Yep.
is why you get two surfaces here.
Yep.
Again, only works at the beginning of a string, not the end of a string.
Yeah. So as you can see, it's
Very niche.
It's reading. Look, it's reading at chainage 60. It's reading the section slope. It was reading it at 20, and it simply transitions that REB code from one to the other. So once we go past 60, it jumps back down to obviously our 3%.
Yeah.
That was the best way we could think to explain it. That's why we put them as miscellaneous, because they are very niche, specific, and only really achieve one thing. You may find that you get huge benefit from these, and if you do, please tell us, because it's great to hear how customers are utilizing these features and actually doing something quite interesting with them. So if you do find that you are getting some success in a certain area, now you've maybe understood what these do. It's great to give us that feedback. You can email me directly, or email Todd directly, or go through the help system and say, hey, look, we've established a good way of utilizing this particular tool. But yeah, thank you, Todd, for your contribution to this webinar. And
thank you, Jonathan, for your contribution as well.
Co-hosting, co-presenting. There will be more civil site design webinars coming up very regularly. I'm hoping to do another one in early September. And yeah, we look forward to seeing you then. Check out the YouTube channel. Other webinars of real use are on there as well. And yes, we look forward to seeing you all very soon. Thank you.
Have a good afternoon, everyone. Thank you.